competition. It's time for the PhD pitches. So let me explain you very brief and very quick the very simple rules. In this session oriented to bioengineering, we have the pleasure to have with us Maria Martin from Medtronic company, very relevant and large enterprise related to the topic of this session. And Maria and me and Jose Eras from Advantage and Marie Montalvo, she is the coordinator of the PhD Hub project. We will be the people in charge to judge the different pitches. It means that we are going to evaluate your presentation, your contents, how is your topic related to the topic of the session, and so on. Why this evaluation? Because, as you know, there is an award for the first one and as well for the second one. So the rules are very simple. For the pitchers, you have between 3 and 5 minutes, no more. In case of you don't finish in 5 minutes, we will stop your presentation in order to give the same opportunities to all of the members. And the scheme of this session will be the next one. We will start with the pitchers. So we have theoretically 6 pitchers. I am going to check now the names and the availability of them. After those presentations, after those pitches, the idea is that Maria can explain a little bit more about Medtronic company, what type of things they are doing in the company. And then we will finish with, if we have time, I hope that yes, we will finish with questions related to the pitcher or for the pitchers or for Maria from the audience. I know that there are some technical problems with the chat box. Sorry for that. It was something out of our control, under our control. So if anyone has any type of doubt or any type of question for any of the presenters, please raise your hand and we will give you the floor for the question. So starting with the session, let me share very quick my screen. I don't know what is here, the screen. I cannot see now. Oh, yes, sorry. This is the table that we have with the registrations of, 1 second, please. Come on, 1 second, sorry for the delay. Yes, this is the table with the pictures. So I would like to check the availability of them. Sakleen Suleiman, are you ready? Sakleen, are you here? Well, we don't have feedback from Sakleen. In case of Sakleen can join to us, we will give the chance at the end of the last one. Clara Posada, are you here? Clara? No? The same than Sakleen. Alvaro, are you here?
Yep.
Yeah. Thank you, Alvaro. So you will be the first one when I finish with the review of the participants.
Okay, perfect.
Leila, are you here? Leila Yousefi? Leila? No? Okay. Nitin Satpute, are you here?
Yes, thank you.
Okay, Nitin, good morning, welcome.
Good morning.
So you will be the second one after Alvaro, okay?
Perfect, yeah.
And finally, a last minute registration that we appreciate a lot. Anastasia, and Trasha, are you ready?
Hi, yes.
Okay, Anastasia, you will be the third one, okay?
Excuse me.
Yes, who are you? Hello?
Hello.
Who are you? Sorry? Well, I don't know. Well, we are going to start. If Maria give me the okay, Alvaro can be the first one. So please share your presentation if you have, and
Okay,
the
perfect.
floor is yours. I am going to leave the control of, yeah, I think that you can start when you want.
Okay, here is the presentation. Can you see it well?
Yes, we can see.
Okay, perfect. Okay. So, hello everyone. First of all, I want to introduce myself as a personal level. I'm Álvaro Alfayate. I'm a bioinformatician and data scientist who is doing his PhD thesis in the CNIC, that is a very famous cardiovascular research center here in Spain. So first of all, I want to introduce myself as a basketball lover since I was a kid. Also, I love and I enjoy traveling to all the places that I can. But I want to share to you my passion about machine learning and artificial intelligence applied to the healthcare sector and field. So I'm going to give a very short talk about my key points of my PhD thesis that will be focused on mass spectrometry and high throughput technologies applied to personalized medicine. So first of all, as we have heard in the previous sessions, clinical trials has different stages, and now with the COVID crisis worldwide, we can be more linked to this kind of studies. But the first phase that each clinical trial have is what we call the lab studies, which is where I'm working in, that there is a lot of years of research to know the physiopathology behind a specific disease and to analyze the key actors in these routes and pathways. So here in Thematic, we try to extract plasma samples from a lot of patients that has cardiovascular pathologies. And in the old days, all the research scientists had a very small sample size. The technology was quite expensive, and also scientists were focused only on a specific biomarkers because of this high price of technology. But now we can sequence a whole genome by a low price. So almost for a $1,000, we can have the complete genome sequence, and also the same for the proteome profile, which has increased quite exponentially. So now we are in the big data area in biomolecular and clinical studies. We manage more than 600,000 variables and also more than 4,000 patients, like in huge studies and clinical trials like PESA that we are performing now here in our research center. So how we process this big data to extract useful information? Well, we have tons of data coming from the machine that we call mass spectrometer to elucidate that proteome profile. So it's mandatory to apply the bioinformatics analysis in a high throughput way with these big data technologies. So we are developing a lot of software packages and programs based on machine learning algorithms and statistical models, mostly written in R or Python. So we can manage the technical errors from the machines that we create a specific model for that. Also, we manage the variance estimation coming from biological sample when we applied some algorithms. And also we can perform some network analysis based on text mining for information extraction and lateral language processing coming from all the scientific literature that is already published. So this is a really simple flow chart about what we do with this data when we have it filtered. We apply these machine learning algorithms, the unsupervised learning, to reduce that dimensionality of those thousands and thousands of variables, so we can classify our patients based on their profile. Then we apply some quite well-known supervised learning algorithms like logistic regression, random forest, neural networks, and so on, to try to do a quite good diagnosis about the pathology. And finally, we can apply all this information and compile all this information to calculate and extract specific indexes from this plasma. and to establish a cutoff diagnosis to distinguish between patients that have a pathology or not. So in general, these are the main and key concepts and aspects of my PhD thesis in a short time. So thank you, and I hope that you understand everything. So thank you so much.
Okay, thank you, Álvaro, for your presentation and for taking the right time for your presentation. So now is time for the second picture. In that case, is Nitin Satpute.
Yeah, I'm ready.
Please
So,
upload your presentation in order to see your presentation. Okay.
Or shall I directly share the desktop, or do you want me to upload?
No, so share your desktop, sorry.
Okay, perfect. Let me check. Okay, this. Is it visible? The presentation?
We can see your desktop, but not the presentation.
Okay, let me check again. Okay. Sure, now?
It's a very small. Now it's right.
Yeah, perfect.
Okay, that's perfect. So
Yeah, let me just check it. Yeah.
please, when we are
So
ready,
shall I
please
start? Okay. Yeah, I'm starting now. Hi, I'm Nitin Satpute. I'm currently a researcher and PhD student at University of Cordoba under HAPANA project. The HAPANA project is basically high performance soft tissue navigation. My work inside that project is how to accelerate the segmentation and enhancement task for liver cancer diagnosis in order to detect, in order to segment the liver, tumor, and vessels. So I'm working under Professor Joaquin Olivares and Juan Gomez Luna. So yeah, my PhD thesis speech is basically based on my contributions. So these are my contributions. So I would like to pitch my contributions here. So you have to provide the input images which can be provided to the clinician, but clinicians should have that flexibility to get the proper segmentation, the proper enhancement so that they can analyze the images. So, but for that they need to have a various approaches. It can be a deep learning approach, it can be a machine learning approach, or it can be a traditional approach. So for that, we provide a GPU-based implementation in order to provide the acceleration, which gives the 100 times speed up compared to CPU. The advantages are like its data privacy can be preserved. The patient data privacy can be preserved using this approach because it is happening locally. You don't need to transfer data to the centralized server. The second advantage is you can get the segmentation of all three tissues, whatever you need, the liver, the vessels, and the tumors, which are present inside the CT images. The third is you can enhance the CT images with the help of the MR images of the patient. So you have all the proper technologies which can assist clinicians. And also, if the accuracy of the segmentations are not good enough, then we provide that tuning parameter which will help the clinicians to tune the segmentation values of the vessels, liver, or tumors. So this is the overall contributions that we have proposed. And then this is one of the contributions, like how it can be done from CPU to GPU. So what is happening, we are sending the data from host, which is CPU, to the GPU, and the GPU will perform all the computations, which is enhancement, the Shanways, which is one of the segmentation approach, and the final segmented value, the final segmented picture will come on the CPU. So what happens, you are sending the data to the device, and this can be one of the devices which is performing the segmentation. Suppose you have enough volume of slices. So what will happen, you will invoke the number of devices, and this number of devices will try to segment each and every slice of the particular volume. So in this way, this particular thing is happening locally also. So you are preserving the data, and then you have enough scope to tune the parameter, which is K, which I will show in the performance results, so that the clinicians can play with the accuracy of the results. So this is one of the implementations that I have shown. So finally, you can see this is the traditional approach happening on the original slices. You can see the false positives here. If you can see my arrow, but in figure A2, but these false positives are reduced in figure B4 by applying our proposed methodology on the enhanced images. This is the enhanced image. So you can compare with the ground truth, and the results are like very good, which compared to the original slices, the false positives are reduced. This is for the vessel segmentations. As I told you, we are providing the tuning parameter K, which can provide the flexibility for the clinicians to perform the segmentations, to vary the segmentations. And finally, as I told you, that along with the liver and vessels, we are providing the tumor segmentations. So based on these contributions, we have published the 3 articles which are published in the Q1 rank journals as a first author, and then which has impact factor of 3.5, approximately 3.5, you can see here. So this is all. Thank you very much for your attention. If you have any questions, please ask.
Thank you, Nitin. Thank you very much for fixing to the time. So thank you very much for your presentation. And next one is, if I am not wrong, Anastasia. So.
Hi. Yes,
hi,
I shall
Anastasia.
share my screen now.
Yeah, please. Yeah.
Do you see the presentation?
Presentation.
You see
you can
it?
Start. Yes,
okay, great.
You can start when you want.
Yeah, so hello everyone, my name is Anastasia Dracha and I'm a first year PhD student at the Faculty of Electrical and Computer Engineering in the Aristotle University of Thessaloniki, researching on digital biomarkers for neurodegenerative diseases. Globally, more than 50 million people suffer from dementia, with the vast majority of them dealing with Alzheimer's disease, and 10 million people more are added each year. Such a high prevalence of the disease will lead the relevant diagnostics and therapeutics market to skyrocket to $11.1 billion by 2024, showcasing the need for innovative diagnostics in this field. Right now, the diagnosis of Alzheimer's disease is done with a suite of neuropsychological, physiological tests alongside brain imaging techniques and laboratory techniques. But these methods fail to efficiently distinguish the prodromal and the earlier stages of the disease, namely mild cognitive impairment, and therefore the treatment process is delayed for the patients. However, with the rise of smart and wearable devices and the extensive range of sensors and the types of behavioral data that can be collected, digital biomarkers emerge as a new diagnostic tool. More specifically, when we move the diagnosis from a clinical to a non-clinical setting, we drop the costs and we increase the accessibility of these methods. Moreover, the unobtrusive passive collection of data at a large scale will give us big data and have a very highly sensitive way to track symptoms. On that note, my PhD thesis will focus on introducing the optimal and novel digital biomarkers extracted from smart devices and the interaction with the users. These biomarkers will be validated within the clinic and in the wild studies, and further deep learning techniques will be developed to predict behavioral changes and track the symptoms. Moreover, personalized digital treatment interventions will be included to have a holistic e-health tool for the patients. As a first study, I try to distinguish people with mild cognitive impairment from healthy controls by the way they are typing on the smartphone, and this has been published in the Frontiers in Digital Health journal. Specifically, we extracted 2 types of features. First, we extracted some features related to fine motor impairment, such as bradykinesia and rigidity, extracted from the keystroke dynamics during routine typing of the users. And then we extracted some features linked with linguistic characteristics, such as vocabulary size, lexical diversity, syntactic complexity through natural language processing techniques. These features and their combinations manage to efficiently discriminate the 2 populations with very high area under the curve and high sensitivity, as it is requested from a remote monitoring tool, and the digital biomarkers used even highly correlated with the clinical scores. Future exploitation of this technology could take 2 ways. On the one hand, there could be an interface for adults over 50 years old that are interested in assessing the risk of developing Alzheimer's disease and engaging in positive lifestyle to delay the cognitive decline. Such app could passively track the symptoms monitoring for the user and offer gamified interventions based on his doctor's instructions. On another note, such tool could be, these digital biomarkers for early disease diagnosis could be integrated for a clinical tool to assist clinical decision-making, patient monitoring, and even revolutionize clinical trials for drug response and therapeutics. Thank you for your attention. I'm open for questions.
Thank you. Thank you very much, Anastasia, for your presentation. And as well, you have fixed your presentation in the right time. So I think that we don't have more pictures because one of them contacted us that is not possible for him to present, and the other two ones are absolutely missing. So I think that we have only 3 very interesting presentations, very different presentations as well, because each of you has addressed different topics. And now I think that it's time to give the floor for one expert in the field, like Maria. So Maria, please. The floor is yours.
Okay, thank you very much, and good afternoon, everyone. My name is Maria Martin. I'm the Training and Education Programs Lead in Medtronic Spain of the Cardiac Rhythm and Heart Failure business. And first of all, I would like to thank Professors Rawan Gardel and the University of Alcalá de Henares for this offering to participate in this interesting event. And I don't know if it's moment to present a brief introduction to Medtronic or to perform some kind of questions to the participants.
I think that you can start with the presentation of Medtronic. Perhaps the audience can have time for thinking about questions for the participants.
Okay, perfect. So let me share my screen. Can you see my screen now?
Yes, we can.
Okay. So Medtronic is a worldwide company of the biomedical technology sector. Let's see if this works. Okay. From our foundation in the latest 40s, our commitment with innovation and collaboration with the healthcare professional has been our continuous mission to improve patient clinical outcomes. In this research through innovation, we cover different solutions and therapies for different kinds of pathologies, as you can see in the screen. More than 70 conditions are aboard from our products and services. And that led to more than 47,000 patents in our global portfolio in the different businesses. So our history of innovation is quite long. From the beginning, we took people we were a startup, as we call now, to our great company we know now of Medtronic. But who is behind this is all the people working in research, as you do, our scientists and engineers that have our human, but also our company investment in this kind of researches. We are a global company along all the world. And better than me, I can share now a video that explains this. Can you see the video now?
We can see just Medtronic logo.
Okay, that's the video. I hope you can listen the audio also.
powered pacemaker, a value instilled in our mission to improve the lives of patients. We call it meaningful spirit that drives us. This belief has propelled us to products that help 2 people every second. We believe patient-focused innovation and strong partnerships are the keys to an even better, more impactful future. With the help of patients, providers, and physicians, we're developing the capabilities that were unimaginable only a decade ago, but are now essential in an era of personalized.
Oh, sorry. Seems that. Sorry for the technical issues. You hear me?
Yeah.
Sorry.
Material science, 3D printing, algorithms, robotics, augmented reality, biosensors, and regenerative medicine are some of the innovative ideas we're using to make an impact, creating a promising future with better health outcomes for patients. Learn more at medtronic.com/innovation.
So there are some drops of what we are doing, and I think a bit related what you shown also. So congratulations. And I don't know if now it's time to perform some questions from maybe from the audience or from myself.
I think that we can start with the audience and then from your side. What do you think?
Yeah, good.
Okay.
Yep.
So anyone from the audience has any questions for our 3 wild pictures? So please raise your hand and unmute your microphone to ask any questions to the pictures or to Maria. Anyone from the audience? Don't be shy. Nikos Barsalekis, please. I'm going to yeah.
Hello.
Hi.
I'm Professor Nikos Varsakelis from Aristotle University of Thessaloniki. Congratulations to the 3 PhD students for the very nice presentation and more very good research work. I would like to ask the 3 students, are there any alternative methods to deal with the problems that you try to solve in your research? And could you say whether your approach is better than the others, or why me as an investor should invest in your proposal or to any other technology, alternative technology? Thank you.
Thank you, Nikos. So, for example, Álvaro, do you mind to start with the question that Professor Nikos asked?
Yes, of course. Thanks so much for that question. I think that the main point here about applying artificial intelligence and machine learning algorithms to the healthcare sector is about the cost and time spent. So we are managing lots of information that a professional clinician couldn't handle it by himself. It's impossible because there are millions and millions of identification, quantification, thousands of patients. So we are providing like tools, lots of tools for that professional to help them to improve their diagnosis. Sometimes it's impossible to improve that diagnosis from the professional because they are quite trained people. But in other occasions, with difficult images, for example, image processing and so on, as the other pitch has shown, time spent by the professional is so huge that it's impossible to give diagnosis for every patient for a specific amount of time. So I think that is the main advantages to apply these technologies.
Thank you, Álvaro. Nitin, Do you mind
Sure.
to answer now?
Yeah, sure. Thank you. Yeah, so yes, there are methods, the alternative methods, which are available, like deep learning, AI-based approaches, and the traditional approaches. So what we provide is the combination of all these things, because in the medical images, it's quite difficult to provide the accurate answer, which are based on the, which are varying based on the clinician to clinicians. The ground truths are also varying. So there are quite a lot of possibilities where you will get inaccurate results, which happen in our cases, which where we were using the deep learning based approaches, but there are many false positives. So what to do in that case? You cannot go all together again and then train your network and come back with the accurate results. It will take a lot of time. Our dream is one day diagnosis and treatment if possible. So what we are trying to achieve, we are trying to provide a framework where we will be having the volume of images, and this volume of images will be processed inside a system so that the overall diagnosis and treatment of the patient can be done in a day. So what will be the advantage? The cost of the patient, cost of the hospitals, the occupancy of the hospitals. They will have to take only less patients, because only one day patients will be diagnosed and treated, and the treatment will be provided and he can go home. So there are a lot many things, and again the data privacy issues. So if your framework is not performing well, you have to retrain it. What happens? You have to send the data to a centralized server. So in between this, you have to take care of the data privacy. It is time consuming process, and also you may lose the data privacy. So how to make sure that? What you can do, what we are trying to do is provide the distributed the hardwares, and these distributed hardwares data will be processed on the basis of the control given by the centralized server. So we will take the information which are not related to the patient from the centralized server. We will try to train our devices and take the accurate results, take the accurate segmentations of the required tissues or organs. So in this way, we are trying to protect the privacy of the patients. We are trying to come up with the real-time implementations which which can solve our dream of one-day diagnosis and treatment, and also it will assist clinicians to the extent which we can improve our technology by providing the flexibility, so that the clinicians can tune the parameters and vary the accuracy of the segmentation or the results which they want. That's all from my side. Thank you.
Thank you, Nitin. Anastasia, your time.
Yes, so as I mentioned in my presentation, the current validated diagnostic methods include this suite of neuropsychological tests or some brain imaging techniques that detect the levels of amyloid protein concentration. However, these techniques are employed way years after the disease has been clinically manifested, although the first symptoms begin even like 10 years before the clinical manifestation. So therefore, we do need some techniques that are more sensitive to these changes happening years before Alzheimer's disease, namely in the stage of mild cognitive impairment. And this is where our digital devices come in hand, because they can detect these behavioral changes through our interaction and provide us a good remote monitoring tool. As far as the specific digital biomarkers are concerned, what we are trying to do is focus on techniques that collect data passively and unobtrusively without messing with the user's daily life and during routine activities. This enables us to have like a wide range of big data that can later on be checked for symptom tracking or monitoring. And on the other hand, we go away from the clinical setting, we go more to a non-clinical setting. We see the natural state of the user, and in a non-clinical setting, it is easier to observe any impairment in executive functions or memory rather than just in the doctor's office. So I think that these are like the drop of the cost and the move to the non-clinical setting and the high sensitivity are the main pillars of our technology.
Thank you, Anastasia. Maria, do you have any question?
Yeah, sure, I have, because the three works are brilliant, really interesting. And I would like to know how mature is your research, or do you see your research to be incorporated in a viable product or service by a company?
We change now the order. Nitin, do you mind to start now?
Sure. So yes, I mean, one of the deliverables inside the Marie Curie project is how to incorporate with the software. So recently, like 1 week before only, we incorporated all the technology, all the algorithms inside the software, which is like based on the Slicer 3D and the Kustus X. So in these two particular softwares, they are incorporated with the help of Python, so that the GUI will be there. This GUI will provide the clinicians to tune the parameters, to provide the input images and check the output of the results. So they are already done, and these results are already incorporated into the softwares, which are 3D Slicer and the Kustus X, and which is one of the deliverables which we recently provided to the European Union. If you want, I can show you that deliverable here, if you want the picture of that deliverable.
Thank you, Nitin. Anastasia?
Yes, so digital biomarkers can be integrated both in a tool towards B2C, like customers, or B2B towards pharma companies or other medtech companies. On the one hand, we need this tool to be integrated directly for patients, so we can gather the large stream of big data that are necessary for the further development and improvement of the algorithms. So the users can have a tool that can track their symptoms, help with early disease diagnosis, and also give them gamified interventions to delay cognitive decline. On the other hand, then clinicians will also need a tool with high sensitivity that can monitor these changes in the executive functions of the patients that the tests cannot detect in their daily life. So it will help with clinical decision making. And the pharmaceutical companies or medtech companies could use this tool for clinical trials to see how specific drugs or other devices interact, help with the symptoms and the deterioration or the progression of the disease for the users. So it's definitely, digital biomarkers can definitely be integrated in a commercialized product.
Okay, thank you. Alvaro?
Well, in my case, most of the software developed is based on that preclinical stage of the clinical trial. So we are mainly focused on processing data coming from quite expensive technologies and machines like mass spectrometry and next generation sequencing. So these high throughput technologies are more related to the academic sector for elucidating the main pathways and so on. But as the software is mainly developed to process big data, it can be also applied for example, for personalized medicine. If a person or a patient has a personal medical device that is receiving loads of data, so we can process it in a fast way. So we can associate a risk factor, for example, to develop migraine or maybe a risk heart failure. So I mean that the software that we are implementing now can be applied also to a personalized healthcare device with any problem.
Okay, thank you very much. And I have another question. It's related to suppose a company would like to give an opportunity to your idea, to your research. What would be the return that the company could have from your solution? What do you think would be the return for the company?
Who wants to start now?
I mean, I can start. I just want to, understand the question again because there was some link problem. So your question is basically what will be the return that company can get from our software, from our solutions, right? So yeah, the product will be a hardware like a cyber physical system kind of thing, which where we will provide the human interventions and also the computing resources, which are based on the GPUs, which are based on the controllers. So overall, it will be like a calcination, like a support, or a CT MRI like a machine, but along the CT scanners provide only the data set. But along with that, if you have some analysis which are coming out of the GPUs, or which are coming out of the cyber physical system, what will happen? The clinicians will get that advantage. So definitely, if you have this particular kind of hardware, the output will be, you can sell it to the hospitals, you can sell it to the clinicians, clinical support, you can sell it to the R&D, research and development, to the universities. So these are the things where you can sell this particular kind of product in order to analyze the patient's data, so that you can the clinicians can see the results, how they are, how exact they are, what can they modify, and how they can be useful for researchers. They can work on that in order to improve the time constraint, in order to improve the accuracy of the results. And also for the clinics, what will happen in the small clinics, what can happen? The small clinics don't have to refer the clinical data of the patient to the centralized big hospitals. They can process their own data inside the clinics, and then they can analyze the data and provide the results to the patients. So these are the features based on what you can sell this particular cyber physical system or embedded device, so that this can be taken. This can be used by the various hospitals, clinics, and the R&D industries. Thank you.
Thank you.
Next one. Alvaro, for example.
Yeah, I start. Okay. I think we are developing quite flexible algorithms that are written on the standard language programming like Python and R. And we are providing algorithms that can manage tons of big data in a fast way. We are talking about 10 minutes, 20 minutes to process terabytes of data, because we use some kind of indexing technology to process this data. So this technology can be applied to any kind of device that has to process big data. And these algorithms that process data in this fast way and so on can be quite cheap and cost effective. And also the hardware that we need to support to run these algorithms can be also be provided by the cloud services that offer a quite cheap cost return. So I think that this software is quite flexible. It can be applied to any kind of medical device and introduced to it.
Thank you.
So from my side, I see two streams. The one way would be that the company would be able to harvest these big data streams with all kinds of types of data, behavioral data, that come from the user's interaction with the devices. And on the other node, there could be an SAS licensing model of both the algorithm that does the early disease diagnosis and the digital biomarkers themselves that can be integrated in other devices in separate interfaces for clinical trials, as I mentioned before, for drug response therapeutics. And eventually could be integrated in a holistic e-health patient-centered tool that can be used for patients to track the progression of the disease, to do some gamified interventions, and to establish the constant communication with the doctor.
Okay, thank you. Have no more questions.
Okay, thank you, Maria. Thank you, the three pitchers. I think that your presentations and your answer for the questions, some of them are not easy to answer, because when you are thinking in your PhD thesis, if someone asks you about the future of how to transfer part of full research to the market, it's complex. So thank you very much. I think that your answers are perfect, in the perfect way, or the way that we expected. And from my side, no more questions. I think that we can close this first session, first pitches. Only just one remark, because in the closing ceremony, we will announce the winner and the second one. Now, of this afternoon, I don't know, we have to speak with Maria. We have to discuss the jury about well, the different things that we are going to evaluate of your work, about your presentation, about your answers. So it could be very complex for us because all of you have done a very, very perfect work. So thank you very much for your time and for your presentations. Even I would like to ask you if you can send us the presentation to share with other PhD candidates, because I am sure that they would like to take your thesis like an example of applied research. That is one of the topics that we are trying to promote in this project, to do research with interest to the business sector or to the non-academia sector. I think that is the right word. And as well, I would like to say thank you very much, a big thank you very much to Maria, because Maria has a very busy agenda. And when we invite her for this session, she answered yes automatically. So thank you, Maria, for your time. Thank you for moderating this session with me, and thank you for your questions as well. So, now we are going to finish this session. And next session is related, the topic is, sorry, I am going to check the agenda, Green City Development, and all the audience who show interest in that session, you receive the link for that session in another channel. So thank you very much to everybody. Thank you, Maria. Thank you, Alvaro. And thank you, Nitin. So I have one raised hand.
Thank you so much.
Paula
Thank
Montero.
you. Thank you so much.
Okay. So thank you, everybody.
Can you hear me?
Who are you, Paula?
Can you hear me?
Paula?
Can you hear me?
Yeah, yes, we can.
Hello. I would just to ask a question to Anastasia. Well, first of all, thank you very much for the presentations. They were really impressive. I'm also a PhD student in architecture, so it's not really related to the topic, but I was concerned about the privacy of the data you are collecting, because if you are trying to detect something so sensitive as Alzheimer, like that's something that can compromise your job, your relationships, and everything. So, how do you manage that? Because you are collecting a huge amount of data, a huge amount of personal data that is really sensitive.
Thank you, Paula. I think that is a very interesting question. Always the data related to health is a very sensitive issue. So, Anastasia, the question is for you.
Yes, of course. Thank you, Paula, for the question. And it's a very valid remark. And that's why our whole system is designed bearing in mind data privacy and security. So all the data coming from the users are pseudo-anonymized, and they are encrypted in a way that you cannot identify which data comes to each user, and the users are with IDs. So it is not, you cannot through our system identify directly who is the person that is connected with which kind of data. So we're trying the whole system to build it like that. And of course, when it comes to communicating data between the user and his doctor, if the interface is set up in this way, then we have to take an explicit permission both from the user and the data for his data to be shared with the doctor. And the data then again is shared in an explainable way. So we do not compromise the personal information, but rather give the doctor the medical, clinical scores and indications he will need for his diagnosis. So it is a very delicate and sensitive issue. And of course, the design of the system is made in a way that would not compromise personal information or health records for any user.
Thank you. Thank you very much, Anastasia. Thank you.
Okay, so I think that there is no more questions. Thank you again for your participation. And Maria, if you have now a couple of minutes, I'm going to call you by another session to discuss about this evaluation. Okay? Thank you very much to everybody.
Thank you very much.
Thank you. Bye.
Pleasure to be with you.
Bye-bye.
Bye. Bye.
Bye-bye.
Okay, welcome to the second session for the pitches.
The icy roads and to maintain the road safety. And as much as it's necessary, It also has led to an increase in chloride ions that are present in freshwater ecosystems, and those chloride concentrations are often higher to be considered very harmful for the freshwater organisms, especially to the species of zooplankton. And my thesis goals are could be divided in two parts. First part is to assess the condition of 5 urban water bodies that are located in the city of Łódź in Poland by describing the zooplankton species composition, their seasonal fluctuation, breeding dynamic, their ability to adapt to selected water pollutants, mainly road salts. And the second part of my PhD thesis will be focusing on solutions that could help to minimize their harmful effects of the pollutants, such as road salts, on zooplankton. And to implement that, I will focus on phytotechnology, which is usage of plants to reduce the concentrations of pollutants. And I will be mainly focusing on salt-tolerant plants that can help to reduce the harmful chloride concentrations in urban water bodies. And by the end of my doctoral studies, I would like to not only better understand how zooplankton may help to maintain the good water quality in urban reservoirs, but I would also like to implement some nature-based solutions that could help increase the resilience of the freshwater ecosystems in the city. Thank you.
Thank you, Alexandra. Thank you very much for your presentation, and thank you for doing it in the right time. So now the floor is for Arnoldo Font. Arnoldo,
okay, can you hear me?
Yes, we can hear you.
Okay, so I am trying to share. Okay. Can you see my presentation?
Yes. Yes, we can see your PowerPoint.
Okay. So my presentation is mostly related to the biotechnological potential of bacteria for the removal of nutrients contaminated in urban rivers. I also work studying at the University of Łódź, and I was just like to tell you that I am a international student from Guatemala, right now doing the thesis here in Europe. So, as my previous colleague mentioned, we are interested in how to recover some of the resources of the city, especially water. In my case, I am also interested in how to treat the water of the cities, especially when they are being highly contaminated by nutrients. Some of them are expressed over here, nutrient sources that require nitrogen or phosphorus. So the high nutrient load actually comes and they enter the system and eventually end up in lakes, where you can see all of these great quantity of algae that could be harmful for life, including for humans. So to address these problems, we have implemented some of a very long name, of course, but these are sequential sedimentation biofilters that can be implemented above the reservoirs to collect all this water and give some primary treatment. Why do we do this? Because we actually want to lower the nutrient load. We want to control the cyanobacteria and reduce the harmful effects. So here is a picture of one of those systems. It's actually, they are divided in many different places, but due to the time, I would not like to exactly the functions that they do, but I want to give you the idea that when the water enters, it has several different types of zones that they provide an ecological function to remove the water, to remove the nutrients by sedimentation, some geochemical processes, including rocks for the absorption of phosphorus. The nitrification is actually removing of nitrogen, and the filtration zone, the use of plants for uptake of some of those nutrients. And eventually the water returns to the lake at the end, or the outlet. Here are some pictures that I would like to share with you that are 3 systems that we are actually working. And we are, well, they are actually located, 2 of them are located in the city of Łódź, and 1 is in the city of Gniezno, which is one of the oldest capitals. The project is actually right now finished. Most of the experiments are finished, and one of them is you can actually visit our first publication, which is cited on below of this graph. And I just want to shortly mention some of the best results that we obtained. This is a spatial analysis that we did on the microbial communities that were in the sediment. But the most important, just because of the complexity, is that you can see that the geochemical zones in two of our examples were very different or distantly related from the other zones of the bacteria. And we believe that this is one of the places where we was to focus on how to enhance the microbial activity. Here you can see another map explaining the different colors. The higher the color, the more intensity or activity of microbial communities in the system. And we did the analysis for different seasons. Two of examples, summer and autumn. So you can see that summer is actually more with color of red. It represents there's more activity, which of course is related to the temperature. Autumn, where it's more colder, there is less activity of a microbial community during this season. Of course, again, you can see that the geochemical zones are the ones that are more affected and they do not develop this great quantity of microbial community. Due to this, we offer the possibility to use other materials, and we found that, for example, when you use limestone, they could help to attach some of the bacterial communities that can aid in the removal of nutrients. Finally, when we did all the monitoring of the analysis, we tried to isolate some of these bacteria. We came up at least with 3 or 4 strains that were very good in their development or practically metabolism to remove the nutrients. And one example is Purite, where they were applied in controlled laboratory experiments. And you can see that through the incubation time of hours, all of these nutrients were practically almost reduced to 0% in control. Thank you very much for your time. I hope that it was clear to understand. I know that it was a little bit fast.
I know, but this is the goal, to try to explain as much as possible and as fast as possible to the audience your work related to the topic. So thank you very much for your presentation.
Okay.
And yes, the next one after Arnoldo, we have Pavel Jarosiewicz. Pavel, are you ready? Pavel, we can see your...
Hello, can you hear me?
Yes, we can hear you and we can see your screen. So the floor is yours.
Okay, so I am ready. I can start that now. So hello everyone, my name is Pavel Jarosiewicz. I am also from the University of Łódź, UNESCO Experimental Eco-Hydrology and Applied Ecology. And I feel obliged right now to explain you in just a few words about the eco-hydrology because this word fascinates me a lot. So eco-hydrology is basically about the relationship between ecology and hydrology. So it means how water interacts with the ecological component of the system. And these systems we can understand also by urban area. So basically what we are facing is that in 2015, the global population of 68% will start living in the cities. So with issues such as climate change, overpopulation, urban sprawl, we can expect a growth of tensions and the quality of life decline by this means. So the basic question is how to green the cities, how to green the cities of future. And as you can look on the pictures, you can see the approach that is proposed by some of the engineers. Let's say this is the techno garden, how they say, and on the right, you can see the more green approach on the eco-hydrological profound processes. So processes between water and ecological systems. On the right side, you can see the map of the Łódź city. Łódź city is a very interesting case because the city was under the very rapid industrial development in the early 19th, in the late 19th and early 20th century. And during this time, all of the rivers of the city were so much degraded that people of the city decided to hide them underground. So basically, there is no water visible in the city up to the late 20th century. And then the ideas of rehabilitation, revitalization started. So many questions arise, how to green up the city, how to do this. And eco-hydrology was one of the answers. But why eco-hydrology? It is because in the cities, the hydrological cycle is very much impaired. it is impaired not only by impermeable surfaces that are collecting a vast amount of water and generating the flash flood, for instance, but also by the pollutants that are accumulated. So we have the pictures like this when we have the green water, which is not playing the basic ecosystem services that are most important in the urban green areas. As also we have a dangerous situations as a flash flood where the city can be under the water. So the idea now is how to bring the cities more greener. And I think now we have two great approaches. One is very much promoted by the United Nations, and I mean this is the nature-based solutions. And the second one is the idea which is now also proposed by the European Commission, which is based on circular economy. So I think the answer now is how to combine them both. And some ideas are growing, like linking sanitation to energy and food security, grey water reuse for irrigation, green roofs used as providing purified rainwater for the non-consumers usage in the building. But how about pollutants in the water? And here is the topic of my PhD, which is the biocare. So in 2018, we have invented, me and my supervisor, we have invented the idea of biocare. As you can see on the picture, these are the small aggregates coated with a different component. And as you can see here, the components are inside the biopolymer. So the idea was basically that we can put this sorbent into the water, remove the pollution, and then because the biopolymers, they can be removed, we can also use again the pollution. So we are into the circular economy concept. So this idea was awarded with a gold medal during the Concours Lepine International in Paris 2018. And we showed them that the efficiency of this material is very high. We can remove up to 90% of phosphates, which are the major cause of eutrophication and biodiversity decline right now. And then this phosphate can be again a fertilizer. So we are closing the gap. And I just have finished it. I just have finished the project where we have developed a machine, a device to produce the biocare, and it was already tested in the stream where we have reduced the level of phosphorus. And I did some basic experiments about the implementation of this material to the fertilization. So the results are very optimistic, and I hope this material could be an answer for the more efficient gap closing between the circular economy and nature-based solution. So thank you very much for your kind attention. And if you have any questions, I'm open.
Thank you very much for your presentation. And we are going to move for the next one is Ela Mierzejewska. Sorry if I don't pronounce well your surname, Ela.
It's fine. It sounds actually quite correct, so it's all fine. Well, give me a second. I will just
of course
focus right now here. Okay, can you see my screen right now?
Yes, we can. We can hear you.
Okay, perfect. So good afternoon. My name is Ela Mierzejewska, and I'm also from UNESCO Department of Ecohydrology and Applied Ecology from University of Łódź. And the title of my PhD dissertation is as follows: Cocurbits and their secondary metabolites as stimulators of biological remediation of soil contaminated with phenoxyacid herbicide. As I kind of realized that it sounds a little bit too detailed for today's pitch, and I just want to briefly introduce you to a core concept of my PhD thesis and my work generally. It's plants removal of organic contaminants, and today I want to focus on urban areas. As you could hear on the first slide on the title of my PhD dissertation, I'm focusing more on herbicides. But why to talk about the herbicides when talking about cities? Well, actually, I don't know whether you realize or not, but massive amounts of herbicides, and every year more and more, they are used by city authorities, by private owners of the garden in order to get rid of unwanted weeds from lawns, especially from lawns, to keep them quite nice and pure, and also to get rid of unwanted weeds from water reservoirs. And here the long chain reaction starts. We apply the herbicides either in industrial, urban, or agricultural use. Then we have to face a higher level of contaminants in the environment. And then we have to face the toxicological effect on living organisms and eventually the negative effects on human health also. We can see a lot of articles saying that herbicides can exert very negative effects on the behavioral and physiological changes in animals, especially water organisms when talking about phenoxyherbicides. And here comes the legislation, either the prevention or the treatment. And here my work comes to the point. So I'm taking care of the treatment, and especially I'm focusing on nature-based solutions, meaning biological methods, in order to get rid of these residuals and metabolites which can exert the negative effects. So the core concept of my work is actually phytoremediation. So simply using plants for a remedy of the environment, either soil or water. And the point is, when you're working with plants, you have to face the fact that they can be very, very picky. So you have to choose and select the plant species that can deal with high stress level in the environment, and especially when we are talking about the contaminants, it has to be tolerant to certain contaminants. And here comes zucchini, which might be a bit surprising, but here is my model plant, which can be used for the phytoremediation, and I can assure you that it can clean up the most nasty stuff from the environment. And here a bit of science behind. So if we are talking about the biodegradation, meaning the removal and degradation of the difficult highly hydrophobic organic contaminants from the environment, biodegradation is very slow in bulk soil, but it's much, much faster when we increase the biodiversity and when we design a plant cover in special spots and hotspots, contaminated hotspots, in a way that it will be enhanced. It can be also enhanced by plant substances which are excreted to the root zone, and also the symbiotic microorganisms which I'm working on. So as you can see, it's quite complicated, but very, very interesting. And what about the applicability of the whole thing? Right now, it's very basic, but I can say, and I'm really brave to say that in the future, it can be, my research can be a basis for the development of biostimulator for removal of contaminants. The other thing my research serves as a kind of increasing awareness, but the plant cover with selected multi-purpose plants can serve as a good zone for removing the contaminants also from city zones. And it's a massive, massive and a great model for scientific research, and I can do quite a lot of things. And of course, it guarantees the effectiveness over the current alternative in terms of residuals of organic pollutants removal. It can ensure the adaptation to EU law, so we have the legislation checked. And what is most important, I can assure you that working in academy and university, it really made me quite sure that increasing awareness on the role of plants in the urban and agricultural areas is quite crucial in this case, because the bigger the biodiversity, the easier it is to deal with contaminants with a negative effect of them. Thank you for your attention, and if you want to get some details on the research, I uploaded the presentation on Microsoft Teams, and here are the articles which are considering actually zucchini, 2,4-D MCPA, and phenoxyherbicides, and their removal from environmental matrices. Okay. Thank you very much.
Thank you very much, Ella, for your presentation. Very interesting as well, like your competitors. So thank you very much. And now it's time for the next picture. Is Dimitrios Kyriakou. Dimitrios, are you ready? Hello, Dimitrios. Can you hear me, Dimitrios? Well, I think that is not ready. So if it's not ready, we are going to jump to the next speaker. Is Carlos Cruz, and when Carlos will finish, we will try again with Dimitri. So Carlos, are you ready? Sorry for the inconvenience to see your presentation. Are you ready?
Maybe yes, because I've got problems with the internet connection, but
Okay, you can see the slides?
Yes.
Okay.
Yeah, yes,
okay.
we can see.
So, good afternoon. My name is Carlos. The aim of this presentation is to give a general view of the PhD. I'm working on the Department of Electronics at the University of Alcalá. My research is focused on the energy efficient resources area, and my research proposal is entitled Pilot System for Sustainable Energy Efficient Community. So think for a minute, how would be your life if you could control all the electronic devices you have at home? Or imagine if you have a model based on energy saving that is used to monitor residential communities in order to reallocate energy consumption. So that's basically the general topic of my research. And the first part, I will talk about the introduction and the context of energy efficient. After that, I will highlight what I consider one of the most important parts of my research, the methodology, and finally, I will present some results and future research. Why energy efficient community? Because we can be energy efficient and sustainable. We reduce energy consumption from fossil sources, and finally, we reduce CO2 emissions. The proposed model is in this picture, and the main goals are the sustainable, by design new services for sustainable energy, cooperation, where consumers cooperate for global purposes in an innovative demand response environment system, and safety from design, a secure system architecture and implementation from this design. I will show the model description where the consumer is a user equipped with energy consumption scheduler or energy manager on a portable device, a utility, a set of energy supply, and the main actor, this aggregator, who is in charge of reallocate the demand. On the right, you can see the global scheme of the design with the data flow and communication. The main results are implemented in a very sample and cost-effective technology deployment, and the communication is performed over different protocols like MQTT. The aggregator is implemented with new efficient algorithms, and we have possible computational and communication costs over this efficient platform. And at the end, we plan to have realistic estimation of the demand and establish different identification patterns by artificial intelligence techniques and validate this model at living labs like Birmingham Singular Research Lab. So this is the general topic of my research. Thank you so much for your attention, and you're welcome to some questions here.
Thank you, Carlos, for your presentation. And well, this is the last call for Dimitrios. If you are ready, Dimitrios Kyriakou, are you here? Dimitrios? No? Well, I think that this is the last presentation, and perhaps now is time to share and to learn from the business sector. So I would like to invite now to give some words or some presentation to the representative from the Phenon Horizon, Maciej Kowalczyk. Maciej, are you here?
Yes, hello.
Hello.
Can you hear me? Yeah, okay.
Yeah, perfectly.
Okay. So I have few information, and I will show you, or try to show you a presentation. Okay. Can you see the presentation?
Yes, we can.
Okay, great. Maybe I should start from the beginning. Yeah. Okay.
Sorry, Maciej, we cannot see now the presentation. Perhaps you stop something.
once again.
Not yet. Now. We can see.
Okay. Great. Okay, so few information about the Thena Horizon. We are a group of people who are working together to develop a good living space in cities for over 10 years. And we are based in Poland, in Łódź, actually in the center of Poland. So good information is that we have a little cooperation with Eco-Hydrology Center. So I'm happy that I hear that the Polish people are here and in this international meeting. What is important to us is supporting local government in the current challenge and showing them the possibilities that result from a new trend. With eco-hydrology idea or circular economy idea or new trends in technical uses in good solution with environment. Since 2016, we are and we also have another international project from Interreg project about water drive project about the Baltic Sea region. Our last two projects are Zumura Circularity Center. It's an agreement of the local government to implement the principles of sustainable management. And Water, but I will show you more details. I think this is a different district in the city of Trybunalski recreational district. And the third thing, so they are working right now is the city of Opoczno, which is prepare a local development plan, as well including the trends that we are talking about also in today's meeting. And now we can start. I will show you the more details about Biowater Global Water Hub. It was a project which take us, which we create last year, and we involve 9 partners around Europe. It was also the city from France, Vienna, and couple business partners in this project also, because the project was prepared for the Urban Innovation Action call about the circular economy. And this is the agenda about our work. We start in May with discussion and workshops. As you see, we wanted to know how the condition and design guidelines we can use to create this special part of city, and we create 2 different workshops. On the one we talk about the guidelines, and on the second one we start to create a concept. After this, we decide together with city to implement the Living Labs methods to develop project in details. And in this Living Labs, we create 3 meetings, as you see. The first was about to define the problems and pre-development the implementations. The second was we showed our problems and our goals to these partners, and they give us a feedback, and we create this and we work about this feedback in this second workshop to create some decision what we can do together for this special area in Piotrków Trybunalski. And after this, we create the last workshop to prepare a detailed schedule and milestones, and also schedule of the money which we have to spend to create this area in a good way. So this you see couples of photos from the workshops, and we create the special maps you see. This is our area with Bugaj Resort, and on the end we create some details, concept how to use this area and what local authorities should give from our concept and what we should to build in this area in the real life. And it is very the people which are on our workshops are very interesting and very pleasant of these ideas, and as far as we know, they really want to build this idea in real. And for our for the principles, what we create, as you see, we try to think a lot of different challenge, like challenging the water and green energy sources, also sustainable and recycled materials we want to use on whole of this area, and also it was a big challenge to clean the water. So a lot of information which we have actually from, for example, from one of the PhD today, we know about this and we want to use it to clean the water. And also the very important thing is that we involve a lot of citizens. We engage this community to our living labs. They was there also, and they create some ideas for the community center, enable interaction, community building, to create the educational part of this idea. Most important thing, what was in this call, was about how to implement the circular economy during the water, using the water idea. So as you see, we thought about storm collection, renaturalization, biodiversity, water saving, citizens reaction zone, eco-education, and reusing treated water. So I think this project we manage a lot of ideas how to reuse the water in real life. So right now we are working about another city, which is Opoczno. It's also near in the center of Poland, and if anybody wants from the PhD people who are listening us today, they want to connect with us to create a new idea for this area like City of Opoczno, we are ready to get some information. I'm not sure if I will just send by email information to me, because you can connect directly to me if anybody wants to make some impact on this next city. Okay. Thank you very much.
Thank you, Marce. Thank you very much for your nice presentation. Very attractive project. In fact, the water is always a big challenge and a big problem for all type of cities. So I think that the possibility to scale your approach or even to adapt to new scenarios is a fancy idea, and absolutely it's possible. Thank you very much. So we have just a few minutes. Marce, I don't know if you have some question, or anyone from the audience and have some question for some of our pitches related to her research. Just 5 minutes or 7 minutes we have for discuss. In case of any question, it could be interesting from the audience or for Massive, like the experts from the non-academia sector.
I have actually a question to Arnoldo Font because I don't catch the moment where his the idea is connecting with business. So maybe if Arnoldo.
We can wait for him because he had some troubles with computer as far as I know. So I will, maybe there's another question. So I can try to get him and find.
Okay, so I have the same question to Guido.
Guido?
Yeah.
Yeah. Sure.
Great.
Hey. Yeah. If I catch the question is how to relate my research with the business. Sure.
Yes. Yes. Exactly.
Yeah, I think it is a very big and challenging question because I came from Italy, where there is a very big problem and opportunity to have some public project about renovation of green areas that came from the municipality, but from the citizens. So it's very important how to involve the citizens and the enterprises and local hub to create projects that the bank or foundation or municipality can finance in it. So it is a challenge. So it is very, very challenging because municipalities don't have the money, time, and technical knowledge to a lot of times. Someone yes, but not all the cities. So normally the city about 200,000 citizens have more problem than Madrid or Milan or Brussels or cities like this. So how to the challenge is how to involve this municipality in European project or local project or national projects. This is not so simple.
Okay, so thank you for your answer. So as far as I understand, it still have to be managed. The idea to connect is not clear. Yeah.
No, because is in I don't know in other countries, but in now I understand that in Spain, in Italy, our history, our land management, and our catastro, our rules, a lot of time are not able to let flow the participation and the business approach. It is short in time and in founding recovery.
Okay. Thank you.
Thank you for the question.
I don't know if Arnoldo is ready for now. Ella, you know?
I am here, yes.
Okay, Arnoldo.
Okay, so just to clarify, because I didn't understand the question, I'm sorry.
What is the what kind of opportunity you see between your PhD problem and challenge and business sector?
Oh God, okay, the challenge in the business sector. Well, you don't understand these ideas.
Yeah, because on your presentation, I can't catch this. Maybe I just missed something. But if you can clearly,
I understand what the application would be here, but good idea for the business sector would be also that some of these systems could be also included into patents, and this could be a part of how to apply some of these combined ecological systems and prepare some treatment in strategic areas where the city mostly needs the treatment. One, and the second one would be the bacteria. Right now we have some good prospects. They are potential because we still are doing some tests, but this eventually could also become a part of a patent and then be applied in several places where they could be needed for the treatment of water and also in the business in this topic. I don't know if this clarifies a little bit what you were asking.
Yeah. Yeah. Okay. Now I know that it's still open doors actually for business. Okay.
Yes.
Okay. Okay.
Okay.
So thank you very much.
Okay. Thank you very much. I know that this is a very interesting discussion and there are a lot of open questions between the Massive and the audience, but I regret to say that we need to finish because the other session is still waiting for us. First of all, I want to say thank you to all pitchers. I think that you can find different views about very hot problem like green cities and sustainability. Of course, for all the cities is a very important topic, and each of you has addressed your research or your PhD thesis in very, very interesting topics for a new green city, a new green life. As well, Maciej, thank you very much for your presentation, for your time. I would like just to give you some quick issues. So the Massive and other three members of this audience, we will evaluate your pitches. How do you present? How is that practice? How is that related with the topic of the session? So Massive, please send me your evaluation by email when you can, because the other members have already sent me this information. And in the closing ceremony on Wednesday, we will announce the winners for that session. And finally, just one thing, sorry, because he's calling me for the next session. I would like to inform you that the PhD project is more than this event. So we have developed a platform to connect different researchers around Europe. So if you are interested, please register in the platform. In fact, I think that the system will send you with your email an invitation to join to this initiative, to be in touch with other researchers in your field. I know, for example, I can for the pictures related to bacteria and water. For example, University of Alcalá has in the facilities a research center only for water. So it's a research for water. So it could be a nice idea to approach with them and to discuss and to exchange information and research with them in order to find more interesting and more attractive things. Thank you very much for your time. And well, if you are interested in the next session, please connect with the other room for the last session for pitches. So thank you very much again, all of you. Thank you.
Thank you all.
Bye-bye.
Thank you.
So my name is Nikos Kousias. I'm a PhD student at the Aristotle University of Thessaloniki. And I'm going to present to you my work with title Development of a Low-Cost Sensor for Particulate and Gaseous Pollutants. So first of all, why do we do that? Why do we need to monitor these pollutants? And the answer is that they reduce the quality of the air we breathe, and also some of them contribute to climate change. And so it's vital to measure them and reduce them. Now, especially for particles, and especially for black carbon particles, the technology that exists is like very good, and the estimates are very accurate, but they are also quite big and expensive. So there's currently a big race going on in the industry and academia to reduce the size and the cost of this technology. And you can see some estimates here on the top right of some first systems that are still in the 5,000 range regarding the price. So there is further need for reduction. We also take part in this race, and for that we have chosen to use a sensor which uses the optoacoustic principle. Essentially, what we have is a laser source that is periodically turned on and off.
Mrs. Ubong. Good afternoon. Now, mistake I take call you. Why were you thinking of me? Anything for us? Sligo, that's in Thailand. Yeah, I know this question. I just told you where it is. What application is that? Okay. Okay. There's no harm in spreading your tentacles. Send me the advert. Let me see. I'm happy for you. You're making good strides now. No, that's the way now. That's the way. Just make what's it called? Adjust the time appropriately. I actually saw. I'm actually in a virtual conference now. I just muted my laptop, so I'm on a conference, and I saw somebody who presented a research proposal on checking the toxicity, some ecotoxicity of using parasites. Using pesticides, and its influence to. Abroad here, they have lawns, small grasses along the road and all of those things. So to save costs, they just spray them with pesticides instead of cutting them like normal cutting. So now the lady was teaching her PhD that it's all about checking the level of toxicity, how it has affected underground water and all of those things. So it just came to my mind. Now I just carry my phone. Say make a call you and say no. Make this guy not go get information overload. Just send it to me now. Let me see. So. All right. Good luck.
I can hear you as well, but I face some trouble with the sharing of my screen. I think that maybe I joined as an attendee, something like this. I don't know if Professor Varsakelis can share the presentation that I sent him, or maybe I just present it orally, because I don't have the option of sharing my screen, unfortunately. Sorry, can I just go on with
yeah, yeah. Perhaps it could be better if we can jump to the next one and try and join to the last one. If there is no problem with the next one, is Maria. Maria, do you mind to do your presentation now?
Yes.
Okay. So Filippo, we will contact with you at the end. Okay.
Okay. Perfect. Thanks.
Maria.
Just one moment.
Of course. We can see now your screen, Maria.
Okay. Yeah. Okay.
Better.
Can you hear me?
Yeah.
Okay. Hello. Welcome, everybody. Let's start with my thesis speech about production of microbial oils to convert them into biofuels using vegetable waste and collagenous yeast. Okay. How can we help our planet without giving up our lifestyle and our needs? My name is Maria. I am a PhD student in the University of Alcalá, and I am doing my first year of my thesis in the biofuels unit in the Research Center for Energy, Environment and Technology in Madrid. And I would like to contribute to any ideas or solutions for this question. Well, nowadays, there are problems and needs that we could treat and improve with the research line, which I'm going to explain us today. Problems like air pollution, excess waste, depletion of resources, and needs like high energy demand, low countries transport, and commercial and heavy transport. In my thesis project called Acnidium, we intend to generate microbial oils to later transform into biofuels using vegetable waste as low-cost raw material. So to achieve this goal, oleaginous yeasts are going to be employed. Why? Because these microorganisms have the ability to accumulate lipids, bio-oils, which are susceptible to be transformed into bioenergy such as biodiesel through well-known chemical reactions. Therefore, using fruit waste as carbon source and oleaginous yeast as producer of bio-oils, we could get a biotechnological process whose byproducts could be exploited in various sectors such as energy and transport sectors. But what are the benefits of this research? If we use our waste as feedstock in a process, we are going to give a green output to this residue, in our case, vegetable waste, residual biomass. It is good to the environment and also to the industry due to the low-cost raw material. Besides, we would be recycling, reusing, and recovering elements, matter, and we will be contributing to a circular bioeconomy. On the other hand, the use of microorganisms, for instance, oleaginous yeast, is a pros too. With their employment, we will be obtaining interesting byproducts to transform them in bioenergy, like second generation biodiesel that is non-toxic and more eco-friendly than other fuels. Biodiesel which can be blended with diesel and which is compatible with carbon internal combustion engines. For these reasons and others, this bioprocess could be interesting and attractive to apply in a biorefinery. Finally, I would like to say that if we act now, many environmental problems will be reversible. However, if we keep waiting, probably there will not be turning back. Thank you.
Thank you, Maria. Thank you for your interesting presentation and for using the right time for that. So thank you very much, Maria. So now is time for Daniel Santa Margarita. Daniel, are you ready?
Yeah. Okay. I will show you my screen.
Yeah, please.
I don't know if you see my screen now.
1 second. Yes, we can see your screen. Yeah, okay. Perfect. Better. Thank you, Daniel. The floor is yours.
Okay. So my name is Daniel. I'm researching in the University of Alcalá, and I'm going to present you the importance for the research in power electronics for energy transmission improvement. Spain generates more or less 30 gigawatts of energy from renewable source. Part of this energy is losses in power conversion, transmission, and distribution. I'm an electronic engineer, so I focus on power converters and the improvement of those converters. If we only improve 1% the losses of these converters, 7,000 hours in Spain only with the power of the renewable source, or charge 2 million of smartphones in 2 hours. So it is important to focus